Hi everyone. So I do want to continue and just wrap up our lesson on function notation and evaluating functions. So that was lesson 1-5. So right now we should all be on page 16. We're going to wrap this up and we are going to skip ahead afterwards to adding polynomials, which is on page 20. So stick with me for now and we'll transition into it in a little bit. Okay, so just continuing where we left off, so we did complete question 15 in a separate video, and now we are going to focus on question 16 together. So for question 16, we have g of -3. Now remember, this is function notation, so this is really, if I were to have x here, like this says g of x, we're going to replace every x with a -3. So I have g of -3, so every x is going to become replaced with this -3. So, and don't forget, put parentheses around everything. So this is going to get replaced with a -3, and so is that x. Because originally my g of x is x minus 2x squared. Replace all the x's, so we're going to put these in parentheses. Parentheses minus 2 parentheses squared. Doesn't matter if it's another variable, whatever it is, I want parentheses around whatever you're inputting or replacing. That comes from whatever is inside the parentheses. So I'm going to replace this x with a -3, a -3, and guess what? This all goes in the calculator. Put it all in the calculator. You don't need to do this by hand. Okay, when you put this all in the calculator, you should end up getting -21. All right. I am going to do question 18 with you as well. If you want, I would give 17 a try. That's some good practice. Okay, so I'm requiring 17. Sorry, not if you want. You got to do it. Okay, so for question 18, I'm going to break this up. I have g of -10 and I have f of -1. So I want to break these up into two different functions. That way I don't confuse myself. So let's do g of -10 here, and we'll do f of -1 here. And then we'll add them together because in the end they're going to be added. So I have g of -10. Well, again, here's my function for g of x. So I have parentheses minus 2 parentheses squared. And looking at my function for f of x, which is here, I will have 2 parentheses plus 6. Okay, we are going to plug in accordingly. So here we have -10 is x, so I'm going to replace all these spaces with a -10. I'm going to put that in my calculator. And g of -10 ends up being -210. And f of -1. Those spaces, guys, this is actually like a nice helpful way for you too. Like those parentheses is what's going to go in there from the parentheses of f of x or g of x. So there's going to be my -1. Put that in the calculator and I end up getting 4. Now we're not done, because finally what we have to do is we need to now sum them. So we are going to sum them together. So I'm going to add g of -10 plus f of -1. I already know g of -10. It's right here. And I'm going to sum them, add. I already know f of -1. It's right here. So in the end, I end up getting -206. Okay, fantastic. Let's do question 19. Actually, you know what? You're going to do it. I want you to try question 19. This is a Regents question. So give question 19 a try, remembering what I told you. Maybe it even helps to color code them the way I have been doing. So now we're evaluating the function f of x. So I have f of x. We have x over 2 minus 6, and we want to evaluate f of 10. So immediately, just giving you that little hint here, you should be remembering now, or writing down, x is now 10 and replacing it. So go ahead, give that one a try. Okay, now number 20 here is a little tricky. So actually, and this comes from a Regents as well, guys, so I am just going to show you this. This is a harder kind of question. From a Regents, now, f of x, right? We have x as our input, so let's do this. So x is my input, that's the input. F of x in total, that's my output. And remember in our last lesson when we talked about domain and range, my input is x, my output is y. So I could technically, if I have f of x equals 2x minus 3, That's really just y equals 2x minus 3, if I were to graph it. Okay, if I were to graph it. Similarly here with g of x, the entire thing is my output, which is y, but my input is x, which again, if I were to graph this, it would be, so I have g of x equals 3 over 2x plus 1, where y equals 3 over 2x plus 1. We are going to graph this because I actually want to show you guys something instead of doing a lot of work by hand. So let's take out our calculators and we're going to graph this. All right, so I'm going to go to y equals in my calculator. So you can see my calculator here. I'm going to go to y equals, and we are graphing 2x is right here, minus 3. And we are also graphing, now this is g of x. So g of x is my second value. See how you have y1 and y2? So y1 right now is my f of x. y2 is my g of x. Now, for my y2, our function is, and this comes from your notes, guys, it's right on the screen, is 3 over 2x plus 1. Now, I want that fraction. So if I want to put a fraction, I can do alpha y equals enter. And now you can see we have a fraction here. We are mostly going to be using that fraction button, but say you forgot, we can just go back and just use parentheses. 3 divided by 2x. 3 divided by 2, sorry, times x. Times x. And we have plus 1, right? Now, we're going to go to the table. So I'm going to do second graph. Here's my table. Now, if you guys notice our answer choices, do you see how we have? Here's when x is 0, when x is 8, 2, and 4. We want to know which of these is true. Well, let's see. When x is 0, for f of x, so f of x is, if I can get my pencil here, f of x is this column, g of x is this column. So for f of x, when x is 0, is its y value bigger than this column? Well, let's look. If I'm at x being 0, and my f of x is -3, -3 is not bigger than 1. So this is out. Now we want to see when x is 8. X is 8. Are they equal? So I'm going to scroll down. And yeah, their values here, oops, erase that. Their values here are the same when x equals 8. So this is my solution. Okay, hopefully that was helpful. Okay, and that is going to conclude our lesson on evaluating functions. We are going to start and take a look at adding polynomials. Okay, so just to begin, with adding polynomials, we want to establish some basic definitions. So for our first definition, okay, when we're adding polynomials, well, it's right there in the words, a polynomial, nomial, is the sum of monomials, whereas a monomial is a number, a variable. Maybe it's the product of numbers. It's just one term. Okay, it's just one term, a monomial. A binomial has two terms, right? Bi as in bicycle, tri as in tricycle would have three terms. So a monomial is just a single term that we get when we combine like terms. Okay, so this is important. We need to know the difference between a monomial, binomial, and trinomial. Think about like in social studies. I don't know if you've learned this yet, but like mono meaning like one. So if you are monotheistic, you believe in like one God. If you're polytheistic, you believe in like many gods. Okay, so just another way to remember it. You'll probably learn that in social studies. Alrighty, so a little bit more terminology. Guys, terminology is going to be so crucial for us. Like if we don't know the definitions, we won't know how to answer the problems. Okay, so if you need to make flashcards for yourselves, whatever you think is going to be helpful for you to remember this stuff, I would make flashcards of monomial, binomial, trinomial, and everything we're about to talk about here. You need to know these definitions. Okay, so the degree of a polynomial that is the highest exponent. That's the highest exponent in the polynomial. The leading coefficient is the coefficient of the term with the highest exponent, again, in the polynomial. A constant is a number that has no variable, so there is no variable for a constant. Standard form of a polynomial, that's the form where the exponents are in descending order. Or we can think about it as like decreasing. Okay, really what I mean here is that we're going from high to low. From high to low. So just to make sense of all of these definitions, I am going to go through the first example with you, and then you guys are going to practice. So let's do this example together. You guys are going to do the second one, and I'm going to do the third one with you. Okay. Okay, so for the first one, we want to make sure these are always written in standard form. Again, standard form, which we wrote here, is from highest to lowest of the exponents, not the numbers, the exponents. So these numbers here needs to be from high to low. And right now, I don't see it going from high to low. I see it going from 4, 5 to 6. So we need to rearrange this. So our first term for standard form has to be 3x to the 6th. Our second term is going to be, let's highlight it in red right there, is negative 2x to the 5th. Our third term, because again, it has to go from high to low order for the exponents, will be plus x to the 4th. There's an invisible plus sign here. And then lastly, we have plus 7. So now we need to identify what is the degree. Well, let's go back to our definition. The degree of a polynomial, so right up here, degree of a polynomial is the highest exponent. So the highest exponent here is 6. So there's my degree. The leading coefficient is the number in front of the degree of the polynomial that has the highest term. So here is my term that has the highest exponent, right? So this term has the highest exponent, but it's the leading number, which is our leading coefficient. So it's the number in front of the variable. So first identify the term that has the highest degree, which is 3x to the 6th, and then take a look at the number in front of the variable. So our leading coefficient here is 3. The constant is the term that has no variable. No variable. The only one that has no variable is right here, 7. So there's my constant, 7. And we already wrote this in standard form right here. So really this information goes right here. Okay, you guys are going to try 2. I'm going to go over 3 with you. So maybe take a second to try 2, and then we'll do 3 together. Okay, for question 3, the degree, again, going back to my definitions up here, the degree of a polynomial, where is the term the highest with the highest exponent? Well, right here, x cubed. The degree, the highest value is 3. So my degree is 3. Don't be fooled by this next piece. The leading coefficient is the coefficient of the term with the highest exponent. This is not your leading coefficient. X squared is not your highest exponent. So I have to look at the term with the highest exponent, and we said that's x cubed. Well, what's the number in front of x cubed? What's the number? The number in front of x cubed, there's an invisible 1. That's my leading coefficient. I'm telling you right now, you'll see on a multiple choice that it's negative 2. Don't be fooled, because this is not written in the correct order. Okay, our constant is the number without a variable. Well, all I see are variables. I see x squared, and I see x cubed. So then our constant is 0. I could write plus 0. Right? That's our constant. There's no variable attached to 0. And now if I were to rewrite this in standard form, so let's erase all this and rewrite this in standard form. Remember, the leading exponent has to come out first, the degree of the polynomial with the highest exponent, which is this x cubed. So our x cubed will be first, followed by, and it goes in descending order from highest to lowest. Okay? So that is how we would write this from highest to lowest in standard form. I am going to pause us here for the day just so we can get some practice in, but hopefully you found this video helpful, and let me know whatever questions you have.